Okay, hello students, welcome to another lecture. And today we will start with the amplitude modulation. So we already know modulation. Modulation. We already know the modulation. It's a process in which you change one of the characteristics of carrier signal. That means you can change either amplitude, frequency, or phase of carrier in according with the message signal. So you have two types of signals. One is your message signal. That means information carrying signal. That's called a message signal. Signal or modulating signal, modulating signal or baseband signal or baseband signal. So these are one of the same name for message signal. So we have one signal that's message signal, another signal that's used as a carrier, that's C of t, denoted by C of t. It's called as carrier signal. Carrier signal. And usually we have sinusoidal signal, that's sine or cos signal for the sine or cosine signal you are using for the purpose of transmission, which will act as a carrier signal. So you just remember. So we're already done with the modulation. I will write, before going for the amplitude modulation, I will write the definition of modulation again. We have modulation. I will write the definition again. Uh, it's a process. It is a process. It is a process uh, in which one parameter, in which one parameter, one of the characteristics parameter, that means one of the characteristics parameter, one of the characteristics parameter, in which one of the characteristics parameter, in which, okay, so we have in which one of the characteristics parameter, one of the characteristic parameter, one of the characteristic parameter, one of the characteristics parameter. Now, what are these characteristic parameters? They can be amplitude, or you will have frequency or phase. That means you're changing any one of these parameters of carrier signal, of carrier signal, of carrier signal, but this change should be in accordance with your baseband signal. Carrier signal, one of the parameters of the carrier signal will be varied. That means you're changing these parameters will be varied in accordance with your message signal. In accordance with message signal. A message signal is also called as baseband signal, or it is also called as modulating signal. Anybody having confusion for this definition, or anybody having any query, please tell me. Then we will proceed to our topic that's called amplitude modulation. Tell me.
No, sir.
Okay. So you are varying the parameters of your message, this carrier signal, in accordance with your message signal. When I say the message signal, you just must note here that this variation is the variation of peak amplitude of, or amplitude or peak or amplitude variation of message signal. Amplitude variation of message signal. You must remember this variation. So now we will have a definition that's important topic today. That's we will start with amplitude modulation. We have amplitude modulation. Amplitude, amplitude, amplitude modulation. So amplitude modulation, it's because this is one of the modulation process, because we have modulation can be broadly classified into two types. One is amplitude. Before going for the amplitude, I will write down, because I have already told you people about this modulation. It's two types. One is amplitude modulation, another one is angle modulation. This one is amplitude modulation. Angle modulation itself divided into frequency modulation, and you have phase modulation. So first we will start with this modulation, that's called amplitude modulation. Now, before going for in detail analysis of the amplitude modulation, we must write down its definition. It's nothing that means you are varying the characteristic, one of the characteristics of each signal, carrier signal, but this characteristic should be amplitude. That means you are varying the amplitude of carrier in accordance with your message signal, in accordance with your linear variation should be in accordance with the message signal. That means whatever waveform you have, whatever envelope you have of the message signal, that accordingly, in accordance with that, you vary your carrier signal. And carrier signal usually we have two types. Usually for the transmission, that is pure sinusoidal. Why we're using sinusoidal signals for the transmission? Because reason is because cos and sine, they are pure signals, they have only one frequency component, and there are less chances of interference, because they are pure signals. Pure means they have only one spectral component, that we have already discussed in Fourier transform and Fourier series. So I will write the definition of this. So it's a process. It is it is the process. It is the process in which peak amplitude, peak peak amplitude of carrier in which peak amplitude of the carrier signal will be varied will be varied linearly. You just remember this. Peak amplitude will be varied linearly with respect to the message signal. With respect to message signal. With respect to message signal. With respect to message signal amplitude variation. With respect to the amplitude variations. Just remember this. This is the definition of this. So that means this is a process in which you vary the in which peak amplitude of carrier signal is varied or will be varied linearly in accordance with respect to, yeah, in accordance with the message signals amplitude variation. This is a definition of amplitude modulation. Now the expression for this, because we need the derivation for the same, expression for the same. So we will have this equation for amplitude modulation. So analysis of amplitude modulation or equation analysis. So first of all, you will assume let message signal be m of t. So you assume we have a message signal, assume we have a message signal m of t. So m of t is nothing but your message signal. Now, I told you that carrier signal, whenever I say carrier signal, you just remember that this must be sinusoidal signal, because the reason is this is purely, this contains this pure signal, means this contains only single frequency component, that you should remember. So you have a carrier signal. I will write the expression for the carrier signal, that's denoted by carrier signal. It's denoted by C of t, and its value is equal to AC. It can be cos or sine. I will write down there cos 2 pi FCT. FC is the frequency of carrier signal. Frequency of carrier signal is frequency of C of t. That means frequency of carrier signal. Now you will write the general expression for this. So general expression, that means that is SAMT. It will be, so SAMT, that means general expression for the AM wave. So AM wave will be described like this. So amplitude modulated wave, because finally after modulation what you will get some signal that you can represent by that you will represent by SAMT that is equal to A cos of, that's will be represented by A cos of twice by FCT. Done. So that's equal. Now where this A will be equal to, where A will be equal to AC plus MT. You just remember this. Where A will be equal to AC plus MT. Now put this value into the above equation. This value, put this value into first equation. Put the value of A in first equation, you will get AM of T is equal to AC plus M of T and cos of twice by FCT. So this is the final value which you will get after this. So this is the final value which you will get after this. Done? So this is SAMT. This is the value and that's equal to AC. AC is nothing but your amplitude of carrier signal, and this amplitude of carrier signal, and this is your message signal. Done? And this is your cos 2 pi FCT. Now this can be further written like this. Just see. If I will take AC as common, what I will get? Please somebody respond. If I will take AC common from this, what I will get? 1. Please tell me.
1
1. 1 plus
1
1
MT.
plus 1 divided by AC, right? Something divided by AC into M of T into cos of twice by FCT, right? And this will be replaced by value Ka, because, and I will replace this by a value. I will replace this by value that's equal to Ka, where Ka is called as amplitude sensitivity of modulator. So this is called as amplitude. Please mute your mic. This is called as amplitude sensitivity for the modulator. Sensitivity for the modulator, right? And you just remember this AC into Ka, it should be always equal to 1. Where AC is the amplitude of carrier signal and Ka is the amplitude sensitivity for the modulator, and its product should be always equal to 1. Done. Now you just expand this equation 3. Try to expand this equation 3. Equation 3, try to expand this. Now what you will get? So we have SAMT equal to AC cos of twice pi FCT plus MT cos of twice pi FCT. So this is the value, and there is also the K, sorry, this K is here also. This K I have not written, so you have Ka. So this is the value of this. So AC cos of twice pi omega CT, and then you have Ka into AC. AC is also here into M of T in this. And these two products should be always equal to 1. So you have written this like this: AC cos of twice pi FCT plus M of T cos of twice pi FCT. Right? And this value is nothing but your carrier signal value. This is your C of t. That means you are adding to the amplitude of C of t, M of t into cos of twice pi FCT to get amplitude modulated wave. This is the final expression of amplitude modulated wave. Okay, anybody having doubt, please tell me.
सर सी ऑफ टी क्या होता है सर?
C of t is, because you came late, I got it. C of t is this. C of t is this. This is your
फ्रीक्वेंसी
C
ना?
of t. No, no, this is not the frequency. C of t is your carrier signal, and it's equal to AC cos of 2i pi fct. It's a signal, sinusoidal signal having amplitude AC and frequency fc. This is a sinusoidal signal having frequency fc and amplitude AC, right? Peak amplitude rather. Okay,
यस सर.
okay. Anybody else?
नो सर.
So you have this modulated signal. We have one carrier signal and additional component. And this additional component is called as modulated component signal. This is your carrier signal, and this is modulated signal component. And because of additional carrier, because in case of you require this additional, you require this power will be wasted, but demodulation becomes easy. Carrier transmitter power will be wasted because of this thing, because this is additional carrier you are carrying other than this, because this is the information signal which you need. You don't need this signal. So that means there will power will be transmitted, power will be wasted, but this helps in demodulation. Now we will go for the spectrum analysis of amplitude modulation. Spectrum analysis of the signal. Before going for the spectrum analysis, I will tell you one property. Have you heard about the modulation property of Fourier transform? Anybody? We are already done with this, but I will repeat this modulation property because that will be helpful in order to draw its spectrum. In order to draw the spectrum of AM, you must remember the modulation property. So suppose if you have a signal x of t, let its Fourier transform be s x of capital X of f, this be its Fourier transform. Then if I will tell you, oh, then what will be the Fourier transform this? X of t into cos of 2i pi f naught t. Can anybody tell me? This actually is the frequency. You can use the frequency shifting property because cos can be break down in using Euler's formula. E raised power j 2 pi f naught t plus e raised power minus j 2 pi f naught t divided by 2, right? Then you can multiply with x of t and accordingly you will get. If you people are not understanding, then I will make this simple like this. X of t, can I write cos 2 pi f naught t equal to 2 pi e raised power j 2 pi f naught t plus e raised power minus j 2 pi f naught t divided by 2. Can I write like this? Please tell me fast.
Yes, sir.
Okay, I can write like this. Okay, so multiply x of t with this. What you will get? X of t 1 by 2 x of t into e raised power j 2i pi f naught t, right? And again multiply this, we will get 1 by 2 e raised power minus j 2 pi f naught t into x of t. So this is your final value of signal. Now we know that if we have x of t, its value is equal to, for that means Fourier transform is x of omega. If you will multiply this by some exponential component e raised power 2i by f naught t or omega naught t, what you will get? You will get x of omega minus omega naught, right? We're done with this already.
Yes, sir.
Frequency shifting property. So by using the same property here, if x of t, its Fourier transform is x of f, then what will be the Fourier transform of this? Similarly, you can tell me the Fourier transform of this one, and then you can add using the linearity property. Tell me. So it will be equal to x of t, Fourier transform is x of f. Then what will the Fourier transform of this? X of f minus f naught, right? Please tell me. Are you with
Yes,
me?
sir.
Okay. So similarly, it will be 1 by 2 x of f plus f naught using frequency shifting property. Using frequency shifting property. Now, final expression x of t, because this can be written as cos of twice pi f naught t, so its value will be equal. Fourier transform value will be 1 by 2 x of f minus f naught plus 1 by 2 x of f plus f naught. So this is my value, final value. Done? Right? Please tell me.
Yes, sir.
Okay, okay. So if I will tell you, suppose let the spectrum of any signal be like this. So suppose we have one x of t is the time domain signal. Let this be like this. Any message signal it carries x of t. Now it's suppose I will say this be its frequency spectrum. So this will be your f and this will be x of f. Obviously it's magnitude spectrum. Now cos of, similarly for cos, what you will get? Wait a minute. Similarly for cos of signal, you can draw its graph like this. Right? So this is t. Similarly, so this is your cos of twice by f naught t. It's, can anybody tell me its spectrum? You have cos of, what you will get? You've already done with this. You have two spikes. One will be at f naught, another will be minus f naught, right? And value will be 1 by 2, 1 by 2, 1 by 2, and this will be also 1 by 2. Done? Because if
Yes, sir.
there will be no amplitude, if amplitude will be AC, then you will get AC by 2, and this will be also AC by 2. We're done with this. We've already studied all these. Now, if you will multiply these two, if you will multiply, and then you, what the value you will get? You will simply say, if you will multiply x of t into AC cos of twice by f naught t, then what you will get? First of all, you draw the graph here. You just draw the graph, try to draw the graph here. By multiplying these two, whenever you will multiply x of t with this signal, carrier signal, you will get the envelope of the message signal, because this, its amplitude is constant. This amplitude is AC. Its amplitude is constant. This is minus AC. Whenever you multiply the message signal, that's x of t, with your carrier signal, you will get the variations of the message signal. That means multiply these two. After multiplying these two, what you will get? You will get the signal like this. So you have like this. This is the variation. Are you getting me? What I will get? I will get variations of amplitude in accordance with my message signal. That is called as modulation. Just remember, so you have the spectrum of this x of t. Similarly, you have the spectrum of your carrier signal. Only 10 minutes. So I will try to finish this. So similarly, then you have AC. Its value will be like this in the time domain. What about its what about its value in frequency domain? What will be its spectrum look like? Spectrum, can anybody tell me? Because spectrum should be like this: 1 by 2 x of f minus f naught, then plus 1 by 2 x of f plus f naught. That means this original spectrum, it will be shifted towards right and left by f naught. It will be shifted by f naught towards right and left. That is the value you will get. Suppose this is the highest value, fm, this is minus fm, then you will see that this value 0, it will be shifted towards right by f naught and towards left by f naught. So ultimately, what is the value you will get here after modulation? Can anybody tell me? Just represent this. You can simply say this is a shifting property which you can apply on this, because final value of this you are getting like 1 by 2 x of f minus f naught, right? 1 by 2 x of f plus f naught. And what is this x of f? This is x of f. This is your x of f. Now you are shifting this x of f towards right and left. That means it will be delayed, as well as there will be some advancement we will be doing. So by f naught. Can anybody tell me what the spectrum will look like? Spectrum will look like same like this. Similarly, we have like this. At this, we have this is minus f naught and this is plus f naught. We have two spikes, that's equal to AC by 2, and this also AC by 2, right? So this is f naught plus fm. So this is f naught minus fm. So this is minus f naught minus fm. This is minus f naught plus fm. So this is your value, final value which you will get. So this is minus f naught minus fm. This is minus f naught plus fm. So this is the final value you will get after modulation. So I can say from his low frequency signal, because what was the range of frequencies in this signal, modulating signal, baseband signal? It was range from 0 to fm. Highest frequency was fm. Now you are shifting your low frequency, that is 0 to f naught, and this is higher frequency. That means you're transforming your kilohertz to megahertz. That's the property of modulation. And by this way, you can reduce the antenna height and you can achieve other things like multiplexing of signals, etc. Got it? So this is in general the modulation property and its spectrum. So in general, I can write down the equation before concluding. X S of t is equal to AC m of t cos of 2i by fct. If you will convert this to Fourier transform, you will get AC by 2. Then this is m of t. It's m of t. You convert this in frequency. Let this be f of m, m of f. So you have m f minus f naught plus m f plus f naught. So this is your final value. That's what is shown in this graph. Anybody having any doubt, please tell me. Hello?
No, sir.
Okay. Okay, thank you. Then you can mark the attendance.